A state's Division of Motor Vehicles, DMV, claims that 60% of teens pass their driving test on the first attempt. An investigative reporter examines an SRS, simple random sample, of the DMV records for 125 teens. 86 of them passed the test on their first try. Is this good evidence that the DMV's claim is incorrect? Carry out a test at the alpha equals 0.05 significance level to answer this question. So, we want to perform a test of the null hypothesis being the proportion is 60% versus the alternate hypothesis where the proportion is not 60%, where P is the actual proportion of teens who pass their driving test on the first attempt. We will perform a test at the alpha equals 0.05 significance level. If conditions are met, we should do a one sample z-test for the population proportion P. All right, so let's go ahead and do our checks. So remember, our first check is if it's random. Okay, so it was an SRS, so that means the sample was randomly selected. All right, so now let's do our normal. Okay, the expected number of successes. So it's our n times p naught, which is equal to 125 times 0.60, which is 75, which is of course bigger than or equal to 10. And then n times 1 minus p naught, right? P naught is equal to 125 times 0.40, which is 50, which is of course not 500, 50, which is bigger than or equal to 10 as well. So our normal condition is satisfied. Our last condition is our independent condition, or our 10%, right? 10% condition. All right. So n equals 125, and big N is the number of teens in this state, right? In this state. Okay, so we have our inequality. N is less than or equal to 1/10 of big N. And then we have 125 is less than or equal to 1/10 of big N, or 1,250 is less than or equal to N. And I'm sure there are more than 1250 teens in this particular state. So we have all conditions are met. All right, so now that all conditions are met, we're going to do our do part. So the sample proportion is p hat is equal to 86 over 125, which is 0.688, right? Or 68.8%. So it at least appears that at least from the sample, that the population proportion might be different than 60%, right? So let's go ahead and find our corresponding statistic. So that is z is equal to p hat minus p naught over the square root of p naught times 1 minus p naught all over n, which is equal to 0.688 minus 0.60 over the square root of 0.60 times 0.40 over 125, which is equal to 2.01. All right, so remember earlier, our alternate hypothesis is p is not equal to 0.60. So this signifies a two-sided test. All right, so we have to account for two sides. Let me go ahead and draw a little diagram. Okay, so here's my picture, right, where I have my critical value. Negative z is equal to negative 2.01, and z is equal to 2.01. So I'm going to see if this area is less than my alpha is equal to 0.05, right? So I know that these both these areas are the same because this is normal and symmetric, right? So I'm going to check my p-value is going to be equal to 2 times the probability that z is bigger than or equal to 2.01, right? Because this is the same here, and there's two of them, right? And this area must be less than 0.05 for us to reject our null, right? So this is equal to 2 times 1 minus the probability that z is less than or equal to 2.01. And now let's go ahead and find that on our table. Okay, so 2.01, so that's 0.9778. So let me go back. So that equals 2 times 1 minus 0.9778. So this is equal to 2 times 0.0222, which is 0.0444, which of course 0.0444 is less than our alpha, which is 0.05. So since our p-value is less than alpha, which is 0.05, we reject the null hypothesis, which stated that the actual proportion of teens that passed their driving test on the first try was 60%. So it appears that a proportion other than 60% of teens pass their driving test on their first attempt.